Alright, welcome back to Fat Mama Physics. In this video, we're going to talk about significant figures. Finally, what I've been alluding to for a long time. So, what are significant figures is one thing I will talk about in this video. We will also talk about how to count the number of significant figures in this video as well. In the next video that I will be doing, I will be going over how to write your answer using the correct number of significant figures when you have to do addition, subtraction, multiplication, division, etc. Whenever I say sig figs, I mean significant figures. And if you're thinking about figs, juicy, yummy, yes, you are correct. That's what I'm talking about. Okay, so what are sig figs? And let's talk about them. First, I like to direct your attention to this line. I don't know how big this line is on your screen, but I like you to make an estimate. Don't look at this text over here. I will not go into it as much. So make an estimate. How long do you think this line is? I hope you didn't say something like 12.53798, etc. Okay, because I'm going to ask you, how confident are you with all those little decimals that you've mentioned in your answer? And if you feel you're very confident with it, I'm sorry, I'm going to call your bluff on that because I don't think you're going to be very confident. We can go ahead and try to measure this, and probably we won't come very close to that. So what does it mean to talk about all these digits? If I, for example, make an estimate and say, well, that's roughly 10 centimeters or something, to you it might be more believable because I sound less sure about my measurement, and I've given an estimate there, which is very general, 10 centimeters, as opposed to 12 point, etc. Okay, so in a way, the more digits that I include in my number, it shows how confident I am with this number. The more digits, the more confident I am with the number itself. The more digits that I can communicate, the more precise the number is. The more specific I can get down to the actual measurement itself. So, for example, if I use a vernier caliper, which maybe you might have seen one of those little, I wish I had one, but imagine I was trying to measure this pen here, and then I can just snap the clamp on my pen, and then as I twist it, I can get down to a few decimal places, like 0.01 or how many in centimeters and meters, millimeters, whatnot. So that's an instrument that can be very precise. It can communicate more digits, as opposed to something like a ruler, which I unfortunately don't have in this room, or like a ruler that I can use a very poor ruler that has centimeter gradients, and it doesn't have those little lines for the millimeter gradients. Then I would have less of a precise number. I wouldn't be able to communicate more digits. Okay, so significant figures is a way for scientists to communicate the precision of their numbers. Okay, so it's that. And when we're talking about significant figures, oftentimes we need to know how many there are in our number to say how confident we are with them. Okay, so that's the practice we're going to do right now. And basically, that's the text that I've written there. You don't need to read that, okay? Okay, so what are the rules? How to count the number of significant figures in your number. First of all, if you have a non-zero number, that is for sure significant. So in example 1, this one over here, how many significant figures are in 8,492? All of them are non-zero. They're either a number between 1 and 9. They are all significant. So there are 4 sig figs here. Okay, why don't you try the next one? How many sig figs on in the next example? Okay, if you say 1, 2, 3, 4, 5, 6 of them, you are totally correct, okay? All right, easy stuff. Now, when it gets a little tricky is when we have to deal with zeros. I came up with this little diagram to help us out. Sure, there are some rules and whatnot, but I think hopefully this diagram visual will help you understand what those rules mean. Okay, so let's say we have a number. visualize two scissors that are either end. They're going to cut zeros that are not significant based on the rules I will tell you in a second. The zeros that they cut will eliminate those zeros in the significant figure count. Okay, so the cut zeros are not significant. That's what it means, okay? So imagine I have these two scissors and I'm going to give them a program. I will tell them how to cut zeros. Let's start off with this scissor here on the left side. What this scissor is programmed to do is it will cut zeros until it hits a non-zero number, either 1 to 9. So it will cut this way, okay, on this number. So for example, right now, it's going to start cutting this first number, and hey, the first number is non-zero, so it's going to stop cutting itself. Stop cutting the zeros. There's no zeros to cut. This other scissor I have here on the right, what it's programmed to do is it will cut zeros unless there is a decimal in the number. If there is a decimal in a number, it relaxes and goes for a vacation. It doesn't do anything. If there is no decimals in the number, it's going to cut until it hits the first non-zero number. And that's what I forgot to write here. Okay, so that's what that scissor is programmed to do. Let's take a look at the first example. It will cut on this side, on the right side, and it's gonna say, oh, there's a zero, I cut you, I cut you, I cut you, you're off the team. Now, we count how many numbers are left, and that's how many sig figs there are. There's 2 left, so in this number there are 2 sig figs. Okay, 2 sig figs. Let's do the same thing for these examples down here. Okay, I have these scissors I'm gonna want to cut here and here. So starting with the one on the left, it's gonna cut, oh hey, there's that's a 0, so it gets rid of you, and you. These scissors over here, it's gonna say, oh hey, there's a decimal in a number. I'm not gonna cut, I'm going off for my break, okay? So we are left with 3 sig figs, and that's what we have. Okay, next one, I have 2 scissors that are gonna try to cut. This one is going to say, oh, hey, whoops, there's a number. I stop. I don't cut. This scissor is going to say, hey, there's a decimal in a number. I don't cut either. Hey, both of them go for a break. We count the numbers. 1, 2, 3, 4, 5. 5 sig figs. Okay? You want to do the next one? Or the next one after that? Haha. All right, then. Pause the video. Give the last 2 a try. Okay, let's do the last 2. Okay, so imagine these scissors. They cut here, nothing to cut because that first one's a number. It's going to try to cut here, but wait a minute, there's a decimal in the number. It's not going to cut at all. We count all these numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sig figs. That's a lot. Okay? Okay, and last but not least, we have this one. We have some scissors here. We have some scissors here. We're going to do some cutting. It hits, oh, hey, it hits a number here. It's not going to cut. And wait a minute, there's a decimal in that number. Means this scissor is not going to cut either. So this one has 1, 2, 3, 4, 5 sig figs. You might have been thrown off by that decimal there. And you might be thinking, well, hey, why is there a decimal? It's not necessary to put a decimal there. And that is why that makes all these little zeros significant in comparison to that first example we saw. Notice I used exactly the same number, but this is a good way for you to, let's say you have a perfect number with the right number of zeros and everything, but if you don't put a decimal, all of those zeros are non-significant. But let's say those zeros are actually significant and you want to communicate that. Good way is to put a decimal there at the end of that number. It tells everyone that all those zeros are significant. Comes down to the point that notice all of these numbers. Okay, first of all, the first thing I want to say and the pattern I want you to notice is the fact that if I put something there, if it doesn't necessarily need to be there, it means there's a reason to do that. Okay? Imagine I am a lazy person. Imagine scientists. We're lazy people. We don't want to do extra work, okay? Why would I put a decimal there? Why would I put these zeros there? Okay, I can just leave my answer there without these zeros and it will convey the same number, okay? But I had to put those zeros there for a reason. Why I need to put those zeros in there? Because I want to tell people that all of those numbers, including those zeros, are significant. I put a decimal there. I want to tell you that everything before that decimal or whatever there is significant, and that's why I'm putting it there. No lazy person is going to do that, okay? And what you might be thinking, well, what about these zeros here? These zeros that are part of the number, they're part of the number. They have to be there anyways. If you don't have those zeros there, then you have the wrong number. You have the wrong magnitude of numbers, okay? You don't have 11. That's completely different than 11,000. Those zeros have to be there anyways. So it's not a matter of laziness or whatnot. That's accuracy. We need to be accurate. Okay, we hold true to whatever we measure in our experiments. Okay, so that's the idea of sig figs, communicating precision. So that's the idea. Here we have a bunch of examples. Okay. And what are we going to do? I'm going to do this. Now that you have a bit of an idea of how to do this, how to find the number of significant figures, remember the two scissors and how they work. Here, let me put them all on the one page. So I'm going to, that's too small. Okay. Anyways, I will, give you a shot of that. Okay, so let's take a look at these examples. Want to try all of them? I think you can do it. So you know what? How about this? You pause the video, try these examples now. Okay, so hopefully you did that, and I will go over it. We'll do it quickly. All right, so number 3, how many sig figs are in this number? Well, there's no decimals, so if I start cutting on both sides, that stops right there. That 4 is significant. I cut from this side. This zero's gone, 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 gone. I'm left with 2 sig figs. Okay, next one, number 4. Same thing. Nothing to cut here, but on the right side, I can get rid of these 2 zeros. Hey, notice there's a 0 in the middle there. That's significant. Okay, that's part of the number itself because there are actual non-zero numbers that follow. If it's stuck in the middle, it is still significant. So, and again, remember the scissors stop. It doesn't come back and try to cut in the middle. It doesn't do that, okay? So the 1, 2, 3, 4, 5. So 5 sig figs, okay? Next one, number 5. How many sig figs are in this number? Got 2 scissors, okay? It stops right there. This is a decimal. This one doesn't cut. We got 5 sig figs again, okay? And the next one, number 6, same thing. We got 2 scissors coming in. It stops right there. There's a decimal. This one doesn't do anything. There is 4 plus 2, total of 6 sig figs. Okay. Number 7, we have these 2 scissors coming in. Hey, this one has a job to do. It gets rid of this one, this one, this one, this one, this one, and this one. These scissors here stop. They don't do anything because there's a decimal. There are 3 numbers left, 3 sig figs. Okay. And last but not least, we have number 8, 2 scissors coming from both sides. The one on the left side starts to cut. This one on the right doesn't do anything because it's a decimal. So a total 1, 2, 3, 4, 5, 6 sig figs again. Okay. So hopefully that's what you got. Okay. Hopefully it wasn't too bad. Remember, think about what a lazy person would do. Actually, what a lazy person wouldn't do. And if they did that, it must be significant. Just like your figs. Okay. All right, and I've been alluding to the fact that why we use scientific notation, how is that easier to communicate sig figs. Here, I'm going to show you why. Okay, don't worry about this. I just talked about that, okay? So let's take a look at 9. How do we count number of sig figs? Well then, we have it right there because if I just multiply by 10 to the power 3, I'm essentially doing 1, 2, 3. I put the decimal there and that's my number. If I have a larger exponent in my 10, let's say there's 9, okay? I'm just going to keep moving that decimal place to make these more zeros. These zeros are not significant anyways because my scissors on the right side are going to cut them up, okay? So it doesn't matter what this 10 to the power of whatever is doing. It doesn't make a difference in terms of number of sig figs. But what does tell us sig figs is that number before the multiplication. And this one here is just 4. And it tells us very clearly exactly how many there are. 4 sig figs. Okay? And if I want to show, let's actually, number 10 is a good example. Let's do 10. So we don't care about this 10 to the power whatever. We have 1, 2, 3, 4, 5, 6. Okay? There are 6 sig figs in this one. And notice there's just a bunch of zeros after that too. And you might be thinking, well, yeah, there's a reason why those zeros are there. Because I could have easily just said this is 2 times 10 to the power of -2, right? Why do I need all those zeros that follow that decimal? And it just means those zeros must be significant. Okay? Very good reason why there. And then number 11, I have 8 times 10 to the power 0. Haha, that's just 1. Anyways, that's just 8. But either way, whatever that is, I could have written 8.0 or 8.000, and I could be more specific, but I'm not more specific. It's just an 8. That's all I'm confident with, and it's just 1 sig fig. Okay, so notice scientific notation really communicates clearly how many sig figs there are. Whenever you're in a pinch and you can't clearly show the number of significant figures, don't hesitate to put it in scientific notation. If you don't remember how to do that, go back to an earlier video, please. Okay, all right, that was it. That was all about how to count sig figs. The next video, we are going to talk about what are the rules when it comes down to adding and subtracting, multiplying, dividing numbers, and communicating your final answer in number sig figs. Okay, so great job watching this video. Thank you for watching. Good luck. I will see you next time on Fat Mama Physics signing out.